Alright class, starting our next lesson, and within today, tomorrow, and actually we'll close out this unit after Wednesday. I'm debating whether to give you a quick quiz slash test on Friday, which will be the second test that you need for this 6 weeks, but it'll only cover like everything from now until like between Monday and Wednesday. So we'll see. Alright, so we're going to start talking about angles, but in order to talk about angles, you're going to need to understand what rays are and how to write them. Okay, I caught some mistakes on these notes, so I'm going to correct them as we go. So an angle is formed by two rays. Okay, so a ray, if you noticed over here on the right hand side, starts with an endpoint and it shoots out, arrow. Okay, you typically can have BA, and there's only one way to write this. Okay, you draw a little example of the ray and you start off with the endpoint letter and the next one. You cannot do AB. That's the mistake I caught. Okay, now for an angle, what's going to happen is you're going to have two rays stuck to each other. Okay, they're connected at a single point, which is called a vertex. That vertex is very important on how you name it. Okay, naming an angle, you use 3 points. The vertex will always be the middle letter. Okay, never switch around the letters when naming an angle and make the vertex one of the first or the last. He always, or she, whatever you want to, the vertex will always be the middle letter. So in this case, that angle right there, I would call it angle ABC, and the only other way I would write this would be angle CBA. Notice that the B, or the vertex, will always be the center letter in the name. Never change it up. Now, here we have the sentence right here, use a single letter if there's only one angle. I would not get used to doing this. Just don't get used to it. Name it by the 3 letters that create the angle. Okay? Vertex always being the center one. And whenever you're talking about the measure of an angle, it's 20 degrees, 15 degrees. You always start with the lowercase m, always, and then the symbol of the angle. Okay, the lowercase m represents measure, and then you have the angle, and then whatever you want to call it. In this case, it's A, B, C. Okay. Types of angles. Hopefully you remember this from middle school. You have acute angles, which means the angle created is less than 90 degrees. You're going to need to know these. Obtuse angles, that means that they're greater than 90 degrees. But the ones that we will probably use the most are the ones that are right or straight angles. The right angle, and you can typically see the box, 90 degrees. That is a right angle. But the other one that people don't pay attention to is the straight one. It creates an exact 180 degree angle. Or you can call it a straight line. A line measures 180 degrees. A straight angle is 180 degrees. So here are our examples. We have example 1. Name the vertex of the angle. In other words, what is the endpoint that both the rays share? What endpoint? Okay. name the sides of the angle, and this is where they made the mistake. Actually, not on this one. This one is correct. So here, sides of the angle are KJ and KL. Those are the two sides. Now if you start catching the patterns, if I tell you that's angle JKL, then I already know that this is one ray and that's another ray. These two and these two. This is my vertex right there. I don't even need to see the angle. I don't need to see a drawing. I know just from the name of it that the middle letter is the vertex and the two letters at the end are the where the arrows are shooting out to. Catch those things. Alright, give 3 ways that you can name this angle. Well, one way is just because, and I know I would really probably never call this angle K. I would call it angle JKL middle, or backwards, angle LKJ. If I were just to look at it, I can classify this as being obtuse. It looks obtuse. It looks like it is more than 90 degrees. Example 2. Name the vertex. Well, I already know it's where they both connect. S. Name the sides. SR, ST. Give 3 ways. Well, 3 ways would be R, RST, or backwards, TSR. And because of this box right there, I know it is a right triangle. Now, congruent angles, we already heard congruent. We kind of know this represents that they are equal. So if angle A is 75 degrees and angle B is 75 degrees, and both of these are equal or congruent. If we continue on to the next page, what we're going to see here is we're going to talk about what's called an angle bisector. We learned when we talked about segments and we were dealing with segments what a segment bisector. It was a line or anything that cut the segment in half. Perfect equal parts. Well, for an angle, if you have an angle and you have an angle bisector, it's a ray that cuts the angle in perfect half, in 2 equal parts. 2 congruent angles. Typically, you will have congruency marks. Okay? Please recognize these marks. For instance, here you have this angle right here is congruent to this angle right here. Simply from the statement that in the diagram BD is an angle bisector. That means that this angle right here is equal to this angle. Now, I could also show it using congruency marks, and they're typically like little dashes on the angles. If they match like those, then they're congruent. They're sometimes double, they're triple marks, little dash marks. You'll notice them. So, angle bisector cuts an angle in half into 2 equal parts. Now we're dealing with more vocabulary words. Perpendicular lines. Well, perpendicular lines intersect at a right angle, which means 90 degrees. The symbol for perpendicular is this one. Get used to it. Start remembering. It's an upside down capital T. So in this case, in this little example, here we have the box that represents 90 degrees. If those two lines are intersecting at perfectly 90 degrees, every single one of these is going to be 90 degrees. Okay, they will all be perpendicular to each other. Perpendicular bisector. Okay, well, we already know angle bisector, segment bisector, cutting things in perfect halves. Well, all a perpendicular bisector does is it cuts in a perfect 90-degree angle plus whatever it bisects or cuts in half, whatever angle it is, and it's typically going to be a straight angle because a straight angle is 180 degrees. A perpendicular bisector will cut that in a 90-degree angle in perfect two congruent pieces. The point where they intersect will be the midpoint. Now here we have question number 3, and here's where the mistake is. But I'll let me erase I'll erase the mistake in a minute. Okay. Write another name for angle CBF. So if I go C, B, F. Okay. Well, all I have to do is make sure that I keep B in the center, so then I go backwards, F, B, C. Now here's the mistake. Name the sides of angle EBD. So if you have angle EBD, well, the two sides, one shoots out this way and one shoots out that way. The only way to write those rays would be ray BD, which is correct, and ray BE, like that, not like this. That is incorrect. Make corrections on your own notes, please. Alright, classify angle ABC. So here's ABC. It is a straight angle. Give an example of an obtuse angle. Well, obtuse is greater than 90. So I'm going to have to figure one out. Let's see. Here we have E, B, C. So we're looking at this angle right here. That is an obtuse angle. Name two that are congruent angles. Okay. Notice how this angle is opposite this angle. Both of those are congruent to each other. So name it with the three letters. B is the center, so EBA is congruent to angle, and it doesn't matter how you want to do it, FBC or CBF. They chose FBC. Name a perpendicular bisector. Here I have this mark and this mark telling me that this piece and this piece are equal to each other. So this just cuts it in half at this point. I notice we have the box, which is 90 degrees. So it's safe to say that BD is my perpendicular bisector. Here we go to example 4. Actually, let's jump over, let's pause here for a sec. Let's see if actually there were none, but you can follow those notes as far as how to name an angle, how to notice an angle bisector, how to notice a perpendicular bisector. What we're going to do now is we're going to interject algebra into all of this. Know your angles. Obtuse angles, greater than 90. Acute, less than 90. Oh, it's a right angle, equals to 90 degrees. Or a straight angle, it is 180 degrees. Or if it's a straight line, 180 degrees. You're going to need to know this for this part. Alright, so let's go. Angle addition postulate. Notice how I typed up here, like in the segment addition postulate, you have to remember that the sum of the parts equal the whole. It will be important that you read the angles correctly so that you know who the vertex is or who that endpoint that they share is, and you can designate, okay, so these are the two angle parts and they equal the bigger angle. And if you look at their example, they're telling you angle ABD, this angle right here, plus angle DBC, this angle right here, is equal to the whole angle, which is ABC. That's this one. The parts. This is the whole. And these are your parts. If you put these together, this is the sum of the parts equal the whole. This angle plus this angle equal that one. So if we take that into consideration, we go into our examples. Again, we start with numeric ABD. So ABD, this is 48. DBC, this is 78. They want to know how much is the whole thing. So that's a simple calculator problem. You just want to know what is, since my stylus would work, 48 plus 78 is equal to 96 degrees. For number 2, they're telling you that DBC is equal to 74. Then ABC, which is the whole thing, is 119. They want to know how much is this guy right here. How much is the tiny one? What's the subtraction problem? 119 minus 74. Then we start working with algebra. But if you remember your lesson here, the sum of the parts equal the whole. So first things first, especially if we have expressions where we're involving x, well, we have to solve for x. I know that this one plus this one, these two added together are going to equal the whole thing. PQR is 141. So I can write this into an algebra problem. 13x plus 4 plus 10x minus 1 equals 141. Combine these and you get 23x. Combine those and you get plus 3 equals 141. You move the 3 across and you get 23x is equal to have the last bit, 23, divide by 23, divide by 23, x is equal to 6. We now have this value. Finding these, we're just gonna substitute this value. So we have PQS. PQS is equal to 13x plus 4. That means it's 13 times whatever x is plus 4. And 13 times 6 ends up being 78 plus 4. And that would be 82. Now the measure of angle SQR equals 10x minus 1, which is 10 times 6 minus 1. That would be 60 minus 1, so it is 59. And such is your problems. Let's move on to the next page. A lot of this is relying on the fact that you are trying to learn this vocabulary so you don't get confused when they tell you what's a straight angle, what's a right angle, obtuse. Take for instance number 6. They're telling you that angle GEF is a straight angle. So that, right off the bat, straight angle equals 180 degrees. That's signaling that to me. Then they tell you that angle DEG, this one is 23x minus 3. So this is 23x minus 3. And GEF is actually 12x plus 8. Okay. We already know that this whole thing is equal to 180. That means that this one and this one added together are going to equal 180 degrees. The sum of the parts equals the whole. So first things first, we got to solve for x. So we have 23x minus 3 plus 12x plus 8. All of that has to equal 180. So I'm going to combine those two together. and I'm going to get 35x. Then I'm going to combine the 3 and the 8, and I'm going to get 5. All of that equals 180. I'm going to minus the 5 to get rid of them on that side, and I'll get 35x is equal to 175. And then it is a division problem. So what is 175 divided by 35? Well, x equals 5. We're done solving for x, so the rest is substitution. Into this angle DEG, into angle GEF, and into angle DEF. Each one of them has a expression. So DEG is 23x minus 3. 23 times 5 minus 3. Which is 112. Then angle GEF. Angle GEF is 12x plus 8, which is 12 times 5 plus 8, and that ends up being, I think, 68, if I'm correct. And then as a trick question, it's asking you how much is angle DEF. I'm not even going to work it out. I know how much it is. Simply because of this straight angle, 180 degrees. Alright, I'll work more out during class.